All right, the concentrations of ions inside and outside of a nerd cell are given below, and the values are obtained when the potential inside the cell is minus 70 millivolts with respect to the outside. And so we're going to use the Nernst equation 3.34 to kind of contemplate this and figure out which one of these makes sense and which ones don't, right? And so what's the Nernst equation? Here we go. V2 minus V1 is RT over F, which is a constant. Say RT over F is just 26.7 millivolts. So 26.7 millivolts over Z. Z is plus 1 minus 1, right? And log of the concentration. All right, so we're calling 2 inside because we've got potential inside relative to outside is minus 70 millivolts. Right? So we're calling 2 inside. So minus 70 millivolts equals 27 millivolts over the charge. So if the charge is plus, right? The charge is plus. This is negative over here. So let's take sodium, potassium. So this part is positive for sodium and potassium, but this side is negative. So what's the concentration telling us? And this again, inside to outside. Well, log of 145 over 15 is positive, and so for sodium, we've got this is negative, and everything over here is positive. So clearly, sodium can't pass through um, the membrane freely, right? All right, let's look at potassium. Well, this is negative. This is positive, but now we've got the log of 5 over 150. That's negative, and we're back into the range where, yep, that could be working, right? And then chlorine, we've got 125 over 9. So this, right, 125 over 9, this term is positive this time, but the Z is minus 1 for the charge, minus 1. And so you've got a negative and a negative here, and it all works out about right. And so if you're looking at the two of these that work, that are free to pass, it's the potassium and the chlorine and the sodium, not so much. All right, that's it on how to understand number 6.